Hello, good evening, and welcome back. Hello, yes. मैं मेरी अभी क्लास चल रही है बाद में बात करूंगा. So, good evening, students, and welcome back for a great, amazing now chapter which is coming before us. As you can see, beautiful discharge lamps, very bright colors, lights. You are very familiar with those lights. You have seen advertisement lights and how glittering they
Yes,
are.
sir.
And you have seen that how during festival seasons these lights are very interesting and look so fascinating. Now you may be wondering that how such beautiful colors are coming and which are the gases which are present in these gas discharge lamps. These are gas discharge lamps. You have seen those advertising
Yes, sir.
colors which
Yes, sir.
you are seeing on the screen, very bright colors where we have written argon, a violet type of beautiful color, and neon. You can see that how beautiful is the color which is coming, and krypton. So today lecture is very important, students, and this will be the last topic of P block elements. And probably
Okay.
you are aware what I am talking about. Group 18 elements. What are these elements known as, students? Group 18 elements. What are these elements known as, students?
Sir, group 18 elements are noble gases.
Noble gases. At one stage, they were called inert gases. And today we call them as noble gases. Noble gases.
Yes, sir.
Okay, correct answer. You are saying that we are discussing about
So, sir, is
noble.
there any difference when we call them noble gases or we call them inert gases?
Yes, yes, we will explain all this. Okay. We will explain
Okay.
to you that they are no longer inert because they do form compounds. Inert means
Okay.
they will not react. And there was a time when compounds were not known for these elements. So they were saying inert.
Okay.
Inert means that they are not going to react. They are not forming any compounds. But today we know that xenon forms a large number of compounds. And one of the compound of krypton fluorides, is also known. Therefore, after the compounds have been prepared, students, the name which has been changed, inert gases have been given off and noble gases have been accepted. So
Okay, sir.
interesting that beautiful gases, and you already know that they are also called, what they are called, aerogens.
Okay.
There was some question somewhere. What are aerogens, student? What are aerogens? Why they are aerogens? What do you mean by aerogens, students? Everywhere between me and students, one thing is clear that we are interacting and thinking all the time.
Yes, sir.
So unless we think, students, unless we understand the basic concepts, the chemistry doesn't work. Chemistry is to be learned, chemistry is to be understood, and it is not something which we say that cramming will be done.
Okay.
Therefore, our job is to decode the NCRT book, because the important point is NCRT, each and every word has a great depth.
Yes, sir.
Either you miss them, that you can pass through them, or you try to go inside them. So we will try to go inside them, students.
Okay.
So why they are called aerogen, student? Can you guess something? Aerogens means that it is a word which is derived from air. Air. That means they are present in the air. That's what we are saying.
Air. Yes, sir.
They are present in
Present
air,
in the
student, though
air.
in very small amounts. So you have very, very small amounts of them in the air also. And since their amount is very small, students, so they are also known as rare gases.
Okay.
I'm talking of gases. They exist as gases, students. They are gases.
Yes, sir.
and they are present in small quantities, very, very small quantities, very, very small quantities. So they are present in our air, student. Very good. They are present in the air. You know which gas we get after liquefaction of the air. You are familiar that what we are getting by the liquefaction of the air. Oxygen is there, nitrogen is there, and which
Oxygen,
gas is
nitrogen,
there? Uh,
helium.
not helium. There is another gas which we are getting. Probably you have seen in other classes like 10th where they were doing fractional distillation. Students,
Mm-hmm.
so it was not air. So argon is a major component.
Okay.
Argon is the major component, student, which can be obtained by liquefaction of air than fractional distillation. I'm talking of
Okay.
liquefaction of air. Every point is important. I hope you are noting, student, every point.
Yes, sir. Yes, sir.
Any question anywhere. Liquefaction of air. And then you do fractional distillation. The word I'm using is important because in chemistry you are using large number of definitions and we understand what is the meaning of that. So they will be first liquefied and only liquid can be distilled.
Mm-hmm. Okay.
Here you have air, you will liquefy them. How will you liquefy the air? Apply pressure, decrease the temperature. Then you will get a liquid oxygen, liquid nitrogen, and you will get a liquid argon. And then you will do the fractional distillation because the boiling points are different. Then you can do it. The boiling points are not different. Then how will you do it? See the story? All this,
Yes, sir.
everything we write, every
Okay.
word I write is important. We to be understood, students. It's not just passing time. So be careful, be alert. Okay, very beautiful. Chemistry is coming. You have said they are rare because they are present in very, very small amount, and uh, they are noble. Also means noble gases. Usually, they are not going to react. You see, they are not going to react at ordinary.
Okay.
They will not react. They are not reacting under ordinary temperature, students, and that is why they were called inert gases at one stage.
Inert gases.
Because they were not reacting. No compounds were known, and therefore they said they are inert. They do not react. They do not react. But now we are saying they are not completely inert. They are not completely inert because we know xenon forms compounds. Compounds of xenon are known with oxygen, fluorine, etc., which are highly electronegative elements. We will see the story. I have written some elements. I have not written every element. You can see, student, the reason you already know that these electronegative elements will have oxidizing ability, will have the power
Ability.
to form
Yes,
some
sir.
compounds. Otherwise, it is not possible. It is not possible. They are inert. So, the noble metals you have heard. So we consider noble metals and then same noble gases. What noble metals you know, student? Can you name some noble metals? Gold, platinum.
Platinum.
They are noble and very, very expensive
Noble
metals.
metal.
You know, they are also present in very small amount and they are not reacting with acids, you know. Even
Yes, sir.
concentrated acid doesn't attack them.
Yes,
You
sir.
know, only aqua regia, you were able to dissolve them. You already know. So interesting. Okay. Next. If we talk of their occurrence, you are saying they are present in very small amount in the, and they are
Atmosphere.
always in the elemental state. Means they are monoatomic. What is the atomicity?
Atomicity 1.
No. ठीक है?
Yes, sir.
Atomicity. Students, they are not forming like O2, N2. Uh, they, They are existing as what you know already: helium, neon, argon, krypton, xenon, radon. We have already shown you. Actually, in the universe, helium is the most abundant element in the universe. And universe, in the universe, you know, the solar system, sun, stars, you have 23% in the universe, 23% as compared to 76% hydrogen. Helium is present in natural gas. Helium is present in natural gas
Natural gas. Okay.
under the earth, under the earth crust. So under the earth crust, you know, where the natural gas deposits are there, it may be around 2 to 7%.
Okay.
We are getting from the natural gas also helium, and is present in small radioactive elements. There are certain radioactive elements which are present under the earth, students, and when they undergo decay, you know, they have a half life. They give a,
Yes, sir.
they emit, you know, helium 2He4, helium, radioactive materials. So they will have some amount of the helium, and certain spring waters may also contain small amounts of these helium, neon, argon. So basically, in air, helium is very small as compared to argon. Argon, helium, and neon are present in very, very small amounts in the air. We have already told you. So therefore, where we are getting them, argon, of course, we can get from air. Others, there are minerals which we said, radioactive minerals are from there. Also, we get helium. And you are aware, you have seen these lamps we have shown. All these are used in gas discharge lamp, and they have beautiful colors. Beautiful colors. Why, what is the reason? We will show everything. So the helium we are saying from natural gas, and there are some amounts which are present. You see from some radioactive material in the radioactive decay. If I consider, student, if we have seen radium is this is our radium atomic number 88. It is a radioactive element, student, and it undergoes nuclear reaction. Nuclear reaction. Radium is converted into radon. So there will be two. So what it gives is helium. So some amount of helium is coming from this. Half life is around 3 point some 8 days. Radium. Radium, you already know, is a radioactive element. So we got familiar with now what the inert gases mean to us.
Yes, sir.
So there are six which we have indicated: helium,
Neon,
neon, argon,
argon,
krypton,
krypton,
xenon,
xenon,
and radon.
radon.
And they have been placed in students group 18. Group 18. ठीक है?
Yes,
And
sir.
what do you mean by that, student? Group 18, you we are talking about the p block elements. In the p block element, you are saying you started with NH2, now you are coming to NP6.
Yes,
NP6.
sir.
So this, the valence shell is complete. Complete octet is there. Therefore, this is a very stable electron configuration. Very stable configuration, students.
Yes, sir.
So the reason stable configuration is that they are not interested to react. They don't
Okay.
want to react, because when you are very stable, then what interest you have? So here they do not want to lose electrons, or they are not interested to gain electrons. Otherwise, because their general electronic configuration is highly stable, electrons in the valence shell are completely filled, and this gives a great stability and stable arrangement of electrons. Stable arrangement of electrons. Therefore, they neither have a tendency to lose or gain.
Gain electrons. But sir, if they don't have a tendency to lose or gain electron, then also we find some compounds.
Yes, we will tell you why. That is the thing. Where we force them to form the compounds. They are not forming themselves, as
Okay.
I said. They are not forming. Oxygen atom is not existing in the atmosphere also. You have O2. We have not done anything. Did we do anything to nitrogen? It formed N2. Did we do anything? There are oxides in the earth crust. Did we do anything? They are forming themselves. But here, what is the story? They are present as such. They are present as such. What we are saying, noble gases. They are living as helium, neon, argon, krypton, xenon. But we try to react to them and form compounds. Then we have to see under what conditions they will form compounds, not under ordinary conditions. They are not interested, but we force them to form the compounds.
Okay.
And chemistry means that we try to do a lot of reactions, and that is how the discovery has taken place. Okay, so you have got certain important information, students. And if I discuss, student, the electronic configuration, we always discuss the electronic configuration. You are saying yes, we
Yes,
always.
sir.
So here, as I go to the period number, student, as I go to the period number, helium is present where? Tell me.
Helium is in first period.
First period, in the first period,
Yes, sir.
you can only have one s orbital.
Yes, sir.
So 1s2. So that is the end of the helium, 1s2. And you could say that there is nothing in the p, then why it is pushed in the p block? Yes, we said there are exceptions. It is exception. You may not put it there, no problem. But its outermost shell is completely filled. It is very stable. It is very stable. Helium. There is nothing in the p. There is no not one p or anything. So 1s2. But still we are keeping it in the family of the inert gas element because the properties are like that, similar.
Okay.
Now, when we come to period number 2, students, period number 2, this is my period number 1. If I put here, period, students, if I put here, period number, you think this is period number 2 starts here. And when period number 2 starts, the last will be what? 2s2, 2p6. And then
Yes, sir.
the first will be 1s2, 1s2. And after that, how many atomic number? You know, this is 2. Add 8, it becomes
8,
10.
18,
Add 8, it becomes 18. This
18.
time 8, 8 because it started with helium, student, first period. Because
Yes, sir.
in other cases, what you find when you started from second period, when we discussed the chemistry of the other elements like
Yes, sir.
carbon family, nitrogen family, oxygen family, we started with which period?
Second
Second
period.
period. So
Second
after
period.
that, you will add 18, 36, and again you are adding 18, then you are adding
18.
32.
Fif-
So this will be
will
54,
be 54.
and then 86.
Then 32 to be 86.
So we have learned the magic numbers. So here the simple was there 8, 8, 18, 18, and then 32. And when we will write the configuration, we are familiar with that, student. How do you write the electronic configuration of these elements? The period number will show the outermost shell number. So the end here will be 1s2 only, 2s2, 2p6, 3s2, 3p6, 4s2, 4p6. And when it becomes 4s2, 4p6, there will be 3d or also completely filled.
Yes,
Here
sir.
4d will be filled, and then you have 2
4D.
completely filled, as well as 5d completely filled. So we see the story of these inert gases. So there's no need to go. We already learned the electronic configuration. And because they are having completely filled shell, there's nothing exception here and nothing unusual as we can see. And they are not going to form compounds, only xenon is forming compound. Chemistry of xenon is known only, rest they are not involved in any chemical bonding. So what we can study, not much about them. Chemical bonding
Okay.
we studied, you see when there will be compounds and you are saying that they are not reacting. but only compounds known are with the xenon compounds are known, and fluoride of krypton is known only KrF2. That's all. Okay? So here, this is our first part. Any doubts here, students? A lot of
No, sir.
information has come. Okay.
Yes, sir.
What do we do next? Every time we are in a group, students, we try to study if there is any table which is given student. It helps us a lot. Tables are very important for us. And when we see the table student, this we already know what is the occurrence, and we have given some idea that this the ores, radioactive pitch blende, monazite, cleveite, these are the name of the minerals from which the helium and sometimes neons are found. Why do I mention sometimes in a question? They may write the name of the ore. You can't stop them. That they will
Okay.
say the ore from which helium can be obtained is. Now, unless I have read it, I will be puzzled. So we sometimes every information is important. Every information is important for us. We should know. Which blend is the name of the ore where helium has been obtained, is being obtained, student. They are under the earth crust. And you have seen, you have heard the story of the discovery of radium. Radium was discovered. Radium was made from which ore? By the Curies. Pitch blende. You know the story in England. That is the ore. Here, monazite cleveite. After this, student, let us see the atomic and physical properties. We always discuss, student, atomic and physical properties. Understanding of this always helps us. What is
Yes.
the story about these elements? So we should have some data with us to discuss this data. Inorganic chemistry means we should have some data. What data we want? We want, if you are talking of atomic radius, I should have a values of that. If we are saying ionization energy, then you will say, okay, give me the values of that. How will I take the values from standard values which are available in the literature, student, which are available in the books. The values we take from that, we don't remember the values. We take the values, standard values are there. That is why the tables are given. From that table, we compare these, and if we see, students, any trends, if we see any exceptions, that is what we are explaining in inorganic chemistry. What I am doing, what you are doing, you are explaining the things which are already there. Data, experimental data is there.
Yes, sir.
But if we can't explain them, then inorganic chemistry is lost. If we can explain, give valid reasons, and then we that we understand the inorganic is very good, and we are comfortable easily scoring, or we are losing 4 marks in exams by giving wrong answers. What is the use? So all this to be learned.
Okay.
So we will try to see what are the values and how we can explain them. First thing you are saying all the noble gases are monoatomic. Monoatomic. ठीक है?
Okay.
So question was asked, why? Why monoatomic? What is your answer, students? What answer
Uh,
will giving in the paper, student? What is the answer?
Sir, noble gases. Uh, So noble gases are monoatomic because they have a completely filled valence shell configuration. So they
Okay,
have little tendency to react.
they have stable, they have stable outer, I'm saying electronic configuration. What is that? NS2 NP6. ठीक है? For
Yes, sir.
helium, we are putting in the bracket NH2. Okay, that's the answer. That's all. We don't have to write on this activity. It's over. Then what we find, students, the atomic radii. Atomic radii. This is where is the atomic radius, student, density, melting point, atomic radius in picometer. These are the values: 120, 160, 190, 200, 220. There are two things here. First, as compared to other elements, students, as compared to other elements of group B block elements, their atomic radii
Will increase down the
are
group.
largest. First thing, I'm not talking about the group yet.
Okay.
Atomic radii are largest in the respective period. In their respective period, I'm saying, students. This is an important point. What I mean, you are coming from group 15, 16, 17, and then 18 in a period. This is a period.
Yes, sir.
So what is happening here? This has the largest size. This has the largest size, student. This is an important point. Now, what is the reason for that, student? Why they are the largest? Why they are the largest, students?
Sir, since they have fully filled orbitals NS2 NP6 configuration, so because of that there will be interelectronic repulsions. So the nuclear force, effective nuclear force will weaken, and hence the size will increase.
There are two reasons we are giving, students.
Okay.
You see that if you have studied the earlier groups, they were not giving atomic radius. What they were writing? I have not written atomic radius there. I have written covalent radius. I never, there was not atomic radii. You have seen covalent radii.
Yes.
Covalent radii, students. Why the covalent radii? When we measure the covalent radii, it is a radii which we are measuring when the compounds are formed. When I say O2, then O doesn't exist as O, it exists as O2. Then I find the covalent radius of O2 and divide by 2, and then I will get the radius of the oxygen. So you have seen
Okay.
covalent radius. Did you see or not? Now I'm pointing out that. I have not given this idea. Now I'm giving you. In earlier, you were talking of covalent radii. And now we are talking of atomic radii, student. And you have already know, may have studied in 11th also, student. These are van der Waals radii. These
Okay.
are van der Waals radii, students, because they exist as monoatomic. Monoatomic. And van der Waals radii are always larger. If you see the 11th class book, you can go back.
Yes, sir. Yes,
Van
sir.
der Waals radii are always larger, students, are larger than covalent or ionic radii or metallic radii, larger than covalent, ionic or metallic, whatever you say. Got it? Radii. They are not forming compounds. We are saying they are monatomic. Second thing, which is more important than this, there is a electron repulsion
Yes, sir.
because their shell is completely filled.
Yes, sir.
So there is electron repulsion which will increase their size. Due to the electron repulsion, students, the size increases. In the exam, question has been given. Both two answer I have given. Second is more important. First is also important. See, I have given two reasons.
Okay.
So both should be written otherwise.
Okay.
Okay, we got the atomic radii. And second, you are saying, now I'm saying that down the group, atomic atomic radius increases. There is no, this is a very normal trend. That answer we already know. What answer you are giving, we don't see any exception here.
Sir, it increases down the group. The
The
atomic
reason
area
we are
increases
writing,
down.
what is the reason you are writing, students?
Sir, as we go down the group, the number of shells
With the
increases, and
addition
so
of
the
new
size
shells,
increases. Yes, sir.
addition of new shells. So we know the answer. We don't have to write much in the anywhere. What is the property which we are using? That should be clear, students. So we have got the electronic configuration. We have the atomic radii, not the covalent radii. Not the covalent radii.
Okay.
I have pointed out that there's a difference between the two. This question, even what is the difference between van der Waals radii, covalent or metallic, or what type of bonding is there, that we should understand. Okay. The third one which we are talking is, students, ionization enthalpy. Ionization enthalpy, students. So what will happen to the ionization enthalpy, student, when I discussed?
Sir, it will be very high.
So we can say that are highest in respective field. First point, ionization enthalpies are highest
In their respective periods.
in respective periods. Though the size is largest, see the story, size is largest, but still ionization energy are highest in the respective periods, becomes a question in the paper. Size is bigger, then you should say that size is bigger, the ionization energy should be small.
Yes, sir.
But then I told you that size which we are talking is the van der Waals radii. But ionization are highest in the respective period. Why, students?
Sir, because they have fully filled outer configuration which is stable, so
You are saying
it will
due
be
to
very difficult to
stable,
take out an electron.
due to stable electronic.
Electronic configuration.
Okay. I hope we have answered this question correctly, students. Everywhere there are so many factors which are operating, and which factor is operating where we have to see. In many questions we have seen more than one factor operates, and the total answer becomes the sum of all these factors. You see that the value of electrode potentials, or there you have ionization energies, then you have hydration energies, all these become involved in certain cases. Sublimation energies, so which is the sum of all these results. Okay, and second thing, as you go down the group, what is happening to the ionization enthalpy? You can see the values. They are always given in kilojoules per mole. 2372 is a quite a high value of ionization enthalpy. 2080152013. You can see some idea about the values help us to understand how much energy is required to remove electron from a neutral gaseous atom.
Yes, sir.
It is quite a high value, 2372 kilojoules per mole in the case of helium. So helium doesn't want to lose an electron, student. As you can see, the electrons are
Okay.
present in the s orbital very close to the nucleus. So you see the big difference, 2372 as compared to this is quite high. And then as you go down the group, what is happening? Here the difference is less as compared to the, always we know, because as you go down the group, as you go to the heavier elements, there is a screening effect coming due to the field d and f orbitals. That we already learned.
Yes, sir.
Transition effect, f orbital effect due to the poor shielding of d and f orbitals.
DNF orbital.
So no issue. We can say that down the group, ionization enthalpy decreases
Decreases.
because it is inversely proportional to atomic radius.
Atomic radius.
Atomic radius. I did not say that in the first case. Only in the second case I am saying that. Why? Because you know the question, depending on the question, the answer has to be given, which factor will operate. So if I give this answer here, then I'm wrong.
Yes, sir.
Because they are the largest in size as compared to other periods. So why should they have a higher ionization enthalpy? So such questions are given students, then sometimes we are confused. Okay, and but you see large increase here, large change here. As you can see, maximum is here. Because helium is one as orbital is very close to the nucleus. And when the effect of, you can see that there is a much less decrease. Here there is a large decrease. Can you see the values?
Yes, sir.
1170
Yes.
to 1037. 1170 to 1137, 1100 to 1100 difference. And here you can see how much is there. More than around 300. So there is a big change.
Okay.
That is expected. We already know, students, that we already know. Okay, we are coming to most important question which has been asked many times. That is the electron gain enthalpy, students. This question has been asked many times in the paper. Electron gain enthalpy, students. Electron gain enthalpy. What is the values? Let us see. Where are the atomic electron gain enthalpy values? These values. Earlier you have seen these values were negative for other groups.
Yes, sir.
For halogens, they were negative.
Negative.
Here, what is important, students? They are positive.
Positive.
Electron gain enthalpies are positive, students. That means what, student? You have to give energy
Right.
to add electron to them.
Electron. Yes, sir.
So that question has been given. Why, which group elements have positive electron gain enthalpy, students? So
Group 18 elements.
group
Okay.
18 elements. Because their outermost shell is completely filled.
Filled.
So they are stable, and therefore if you want to add additional electron, you have to supply energy, students, to them. You
Okay.
have to supply.
So, sir, if we add an electron by giving energy to one of the atoms of a noble metal, then it will go into the outer shell only, the added electron.
Yes, of course. Where did you
So,
know?
so there will be a lot of electronic repulsion.
That is why you already know when the energy is released, student. Energy is released whenever there is an attractive force. And it is a
Yes,
law of
sir.
science only. Unless whenever there will be attractive force between two things, energy will be released. If attractive force is not there, then energy will not be released. Here there is no attractive force. That is why we are supplying energy. As and when anywhere when there will be attractive force, student, energy will be released. When a bond is formed, student, energy is released. When bond will be formed,
Okay.
energy will be released because there is attraction. So every time there is an attraction, what will happen? Energy will be released. And when This is not happening. What is repulsion? So that is why we are supplying energy. That is why the value is positive, students. That's what we are saying. It doesn't want to take electron. We are forcing it. And therefore they have positive electron gain enthalpies, positive electron gain enthalpies. So
Okay.
the values are given, students, that you have to supply energy in order for electron to be added to them, because they have stable stable
Electronic
electronic
configuration.
configuration. They have not no tendency to gain an electron, but we are giving. So electron gain enthalpy we have understood. So next question, what is coming, students? We have, where we are. We have discussed the electron gain enthalpy melting points. What is happening to the melting point, students? Melting point. When I say melting point, melting point is always for solids. There should be the solid state to do the melting. What is happening to the melting point, students? Melting point is increasing.
Increasing.
Melting point is increasing, students. So let me, we have already noted this. This group is important. There will be a lot of questions from this. I'm telling you.
Okay.
Always, these are favorite for all exams. There is no paper in which questions are not given from this topic.
Okay.
Any question can be asked. Though not much chemistry is there, but whatever chemistry is there, there will be 100% question asked on this group, students. As we will study, we'll see something very interesting. Okay, let us see the trends. But we're talking about the physical properties, students. Physical properties. The boards, we have to see what to have. Physical properties, I am talking, students. Physical properties, I'm talking of, student. Melting points. What is the melting point? They are increasing or decreasing down the group?
They are increasing down the group.
Increasing down the group. Give me the reason, students.
Sir, because as we go down the group, the size of the atom is increasing, and hence the van der Waals forces are also increasing. They are becoming
So
stronger,
we can say
and so
that
the
what is happening there. Okay, let me put it this: their atomic mass. They are monatomic here. Atomic mass is increasing down the group.
yes, sir.
Van der Waals force is increasing. Which van der Waals force is involved here? Because there are different type of van der Waals forces you have studied. You studied in 11th class different type of van der Waals forces also, student. What van der Waals force is involved here? Let's see, the point is what van der Waals force is involved here.
Sir, van der Waals forces of attraction. This would
Dispersion.
be dispersion forces. London forces or dispersion
There
forces.
was hydrogen bonding, there was dipole-dipole interaction. Now I am saying van der Waal, but I have to mention here something. This is important word here. They are only induced dipole, which are the weakest forces, are the dispersion van der Waals forces, student. They are not dipole-dipole forces. There is no charge or nothing in them. There is no hydrogen bond or anything. You have seen van der Waal, how many types of van der Waal forces? They were all attractive.
Yes, sir.
So here we are talking of dispersion forces. Every word is important, student. That is my point. They will ask you somewhere in objective type questions that the van der Waal forces which are involved in the noble gases are dispersion, dipole, induced dipole, all these type of things can be asked. Some don't expect a direct question. Study, when we study properly and we know what is the meaning of each and every word, student. That's what I'm saying. Every word has a depth. NCRT book, every word is deep, but how much we understand them? It requires a lot of study and attention. Most of the students are just passing their pages off and they think very difficult to remember. Who is asking you to remember anything? I said, that is the story. Okay, we understood it. Melting point will increase, then no problem. I am using a word mass, atomic mass, which is more important, student. Only when in organic compounds I will be talking about surface area, branching, and other type of things. When the molecular masses are same, when atomic or molecular masses are same, then I discuss the surface area and other type of things. In organic chemistry, you have seen that question has been given on boiling points also in organic chemistry last year.
Okay.
One question is coming like that. Arrange them in the order of increasing boiling point or decreasing boiling point. This question has also been given, but I am telling you, this question has been given in the papers. So every question I am talking has been given somewhere. All right. Next time talking of the boiling point, students. Boiling points. So what is happening to the boiling points? 4.22. Here there is no
Sir, it
difficulty
is
in
also
answering the question of boiling point. You can see that there is an increase.
increase.
There is an increase as you go from helium to what is happening as you are going from helium to Rn is radioactive, so may not be of much interest to us. Boiling point is increasing as you are. If it is given, the value is given, then I have no problem. The value it is increasing, and here there is no bond or anything. It's all monatomic we are talking about. So there is no problem in explaining this also, because the only forces are those weak van der Waals forces, students. Therefore, they are increasing with increase in the masses, with increase in the masses, student. Regular increase due to corresponding increase in magnitude of van der Waals forces. So what is happening? There is an increase in magnitude of van der Waals dispersion force as the molecular mass or atomic mass here. Atomic mass increase. So no difficulty in here up to now. There's no difficulty. Few more things. If we study their properties. Now, if we talk of liquefaction of these gases, students, liquefaction. Say the liquefaction. What will happen? Why do gases will liquefy? Tell me. Why do we Why will gases liquefy, students? Will they
Uh,
be easy to liquefy or difficult to liquefy? That is our question.
okay.
Will they be easy to liquefy or difficult to liquefy? What is your answer, students?
Uh,
What do you think? What you are expecting? Liquefaction should be easy or difficult, students?
Sir, it should be uh, difficult to liquefy noble gases.
Question always with reasoning. What is the reason, student? Whenever you say something, there has to be a reason. In inorganic chemistry is all about reasoning. We are saying it is a difficult to liquefy them because why gases liquefy when there is an attractive
Sir,
force.
because
But if there is a strong attractive force, they will liquefy faster. If there is a weak
yes,
attractive
sir.
force, then why will they form
It will
liquid?
be take time to, yes, sir.
They are difficult to liquefy. Liquefied mean what? What do you mean by gas, liquid, solid? The force of attraction increases when you go from gas to liquid. When you go to solid, the force of attraction is strongest. And when you heat the solid, you are breaking the attractive forces between them. And here the attractive forces are very weak. They have only weak van der Waal
Van der Waal forces.
dispersion force. I'm saying there are so many types of van der Waal forces.
Okay, dispersion forces.
So the forces are very, very weak, student, and therefore it will be very difficult to liquefy them. Very difficult to liquefy. And you will need very, very low temperature and high pressures will be required. And question number 2 here. The ease of liquefaction. Student, question can be anything. Make sure that you don't miss anything. Our lectures are very informative. You won't get this information in the books all the time. Wherever some questions have been given in previous years, we are trying to get them. What will happen to the ease of liquefaction? If I move down the group, student, they will be easier to liquefy or difficult to liquefy.
Sir, down the group, the ease of liquefaction will be increased. They will be
because
liquefied easily.
because their van der Waal forces of attraction will
This
increase
will,
due to increase in
yes,
their
sir.
masses.
Van der Waal forces of
So
attraction.
the mass increases, the ease of liquefaction will increase down the group, student, down the group. So if we think one or two more things, okay, that's all. Yes, since I am talking, let me see what else. Physical properties. Now, what we are saying, if I consider student their solubility in water, their solubility in water is going to be very low because there's water is a polar molecule, but as you go down the group they may show little bit more because the polarization, there is some polarization which will dipole induce dipole because water is polar, there could be dipole. So this slight increase could be there as you go down the group. And you have seen one more property that they are absorption over the charcoal at low temperature, and the extent of
Yes, sir.
absorption increases with the atomic size of the noble gases, students. And if I talk of enthalpy of fusion and vaporization, what will be, they will be high or low? The enthalpy of fusion or vaporization, these values will be high or low, students?
Sir, enthalpy of vaporization.
You already know what is fusion, what is vaporization, what is enthalpy. They are decided by the attractive forces between these particles. Here the attractive force is weak or strong.
Weak.
So they are
Weak.
weak forces. Therefore, these values will be low. These values will be low, and they may increase as you go down the group. They may increase, they will
Okay.
increase as you go down the group, students. ठीक है?
Yes, sir.
So, all right, students, here we have given you complete information about the atomic and physical properties of the noble gases. And very important information has already reached you. You have seen how the questions can be asked in the paper, and each and every word, how do we answer the question, that is important, students. What we answer, we write. We can't write anything. We have to be very specific and short answer in English. There is no need to write
Okay.
things which are not required. Therefore, we'll continue in our next class with more important information. This is an important group, and questions will be coming from noble gases group 18. Always is a favorite topic for all the exams.
Okay, sir.
Okay, then bye bye, and we'll see you in our next class. Thank you very much.
Okay. Thank you, sir.
Okay.
Thank you, sir.